Oh, now it's working. Weird. So I just tried to start streaming and it didn't work for whatever reason. I think it was something to do with OBS probably. But today I'm going to try to convert uh, the Blender Bezier curve, which I'm already trying to do for a couple of days. Just trying to convert the code from Blender that creates a Bezier curve to Godot. So I'm gonna step over the code from the parts. I'm gonna go very fast from the part before, which I already went a bunch of times. So there's two different parts. One is when you add the Bezier curve to the visualization, and the other one is when you add depth. So I'm gonna go over the first part and put breakpoints for both situations. So I'm gonna go from the point that after you add the Bezier curve to follow the functions and see what's going on. And then after I go throughout the loop, I'm going to add the depth and then continue from that part. And what I'm trying to do first is to follow these steps here, which is basically to write down the functions that are used to calculate depth. I already went a little bit to clarify, because there's a bunch of functionality that is related to state on Blender. I'm trying to remove everything and just keep the functionality that's related to creating the points and adding the depth, because what I want is to extract the vertices. So, because that's what I'm going to use on Godot. So, in order to do that, I have to clarify the state. And that is the part that is most annoying, because I think there are some data structures that I'm probably not going to use. Actually, a huge part of the data structure. So basically, I'm going to explain what I understand so far. So basically, everything works based on an object, which they call this OB_edit on some of the functions. And then the data member variable is going to be the curve. And obviously, it's going to depend on what you're rendering. But in my case, there is the curve. So the curve is a struct that has these values here that are the values used. They're going to be displayed as well to manipulate the curve. So they initialize these values first. Then they also have this list base, which is a linked list, as far as I understand now, of added NURBs. The name is added NURB, but it's just a linked list of void pointers. And they append the new data structure, which is a NURBS data structure, which is inside of the curve through this path here. This curve, edit NURB, and then NURBS. And they append that to the end of this edited NURB list here. And this makes the connection with the points in the first place, because the points are created on this NURB new data structure. So as far as I understand, in the first part, this is the thing that matters. The points are saved and stored on the BIST, however you say this, BIST repo, which is just another data structure that they use to hold the information about the points. So it's stored here. Then later on, I already went over a little bit as well, but they're going to use these points here to call other functions that are going to use another data structure, which is curves. Inside of the curves, you have the curve geometry. And this stuff is related to, is part of the thing that I want to remove, because the reason why they did it like this is because in the older version, it used to work with the curve data structure, and then they created this other data structure which is called curves. And they basically have one function that the only purpose is to translate the information from one to the other. So my stuff doesn't make sense to use that, which is just curve legacy to curves function. It translates the NURB information to the curves struct. And the curves struct is the main one that they use to pass or to calculate the points and to do the drawing. So I am trying to separate here in files and put like information on separate files so it's easier to make sense. So the idea that I have is just put copy as much as possible in the beginning, make it easier. And once I have all the functions and everything, then I just try to render. And if I see if it works, I'm going to try to clean up all this stuff here. Initially, I was trying to copy everything, but then I realized that it doesn't make a lot of sense. So this curve geometry is the one that is the biggest one. Has a bunch of stuff here that I basically just commented everything out. And I don't think I'm going to need to use this, because this is the stuff that I'm talking about. It's just related to the state management of Blender's application, and not related to the creation of the vertices. So I think that this custom data struct is the main thing that they use to keep track of the data. And then they use a list, link a list of NURBs. And I think that's this part I'm not really sure as well because I didn't look into it yet. So I'm not really sure how I'm gonna be able to look into it. But basically, when you press E, when you select the curve and you press E on edit mode, it allows you to add another control point to the curve, another point to the curve. And I think that they keep stuff on a linked list because that's how, like, in situations where you have more than one curve, let's say, each one is gonna be one NURB inside of the linked list. So, but I'm not really sure how that works yet. But I think this custom data is the main thing that they use to change the visualization there. That's basically what I'm trying to do now, is trying to parse throughout the data stuff to find what are the relevant things to actually get the vertices that are gonna draw this stuff. Once I have the vertices, then I can just plug that into Godot. So basically, there's a bunch of different things here that are commented out because they use just like in Godot, they have special data structures that allow them to optimize memory and speed. So they create these different classes or structs to handle indices and to handle arrays or lists, lists, and vectors of data, basically, in an optimized way. But I think that it doesn't matter for the stuff that I'm trying to do. This is another kind of annoying part because I'm trying to translate the functions that they use there on the math to calculate everything basically to the data structures that Godot uses. And obviously, I'm not really sure if the conversion that I'm making is correct. So it's gonna be very annoying if I get to the points where I try to render and it doesn't show anything, because then I'm gonna have to spend a bunch of time trying to figure out where the mistakes are. But I think, yeah, it makes a lot more sense to do this, and then, you know, the faster you're able to go through the feedback loop system, the quicker it becomes to draw this stuff. I'm gonna put 2 hours here. So I'm gonna try to do 2 hours, then take a break, and then do another 1 hour and a half or 2 hours stream. So I think that this is basically, this is a linked list, and the NURB data structure, I think, is the main one that they use to update the points. I don't remember which file is that. I think it's on this one, probably. Hey man, thank you. Think so. Someone's asking how long I've been. So this is the main data structure, is the NURB, I think, that I'm going to use. Someone's asking how long I've been learning to code. It's been, I think, 3 years and a half now, approaching 3 years and a half. There's going to be 4 years, I think, at the end of this year, if I remember correctly. But if I go to the oldest, like I streamed, I did learn 1 month before I started streaming, but it wasn't really learning. I kind of took a course from MIT or whatever, but I just took like 2 classes and then I just stopped or something like that. And some time ago, I created an account on GitHub, but I actually didn't learn anything. So I actually started when I really started learning was the moment I started streaming. So they're basically the same time. So it's basically 3 years ago, according to YouTube. And I think, yeah, it was at the end of 2020. So the end of this year is probably going to be 4 years. No. Oh, so I am compiling here, and it seems that everything is working. So everything that I copied so far. And I created this function here as an entry point. So basically here, I'm putting the stuff that is not necessarily related to other functions. It's just the main thing that I'm going to use to create the curves. So this stuff here happens after you add. So I'm going to start now. So basically, I go here, click add curve, Bezier, and I put the breakpoint here. And then there's some function here along the way that they're going to they're going to initialize these data structures, and they're going to update best triple, which is another data structure inside of the null. But here is the thing that was kind of confusing to me, because in this function specifically, it doesn't have anything, like it doesn't connect the curve with the nerve on this function. It just returns the nerve. And then on some other functions, it's gonna do some stuff to connect the nerves with the curves, and then with the curve, and then on the another function is gonna that function there that I showed, this one, is gonna translate the curve into curves, and then the curves is the one that has the curve geometry. And there's a bunch of functions that there's a bunch of different things that are basically just related, as far as I think now, to updating the state because of the way that they manage different objects. There's some explanation on the website, on this page here. I think it's on this one. There's a bunch of stuff here. I read most of them. And yeah, they explain that they try to use the same or share objects, and then there's read and write operations that they, like in the way that they organize things. But it's just basically a bunch of stuff that I think I'm not gonna need to use, because my point is to just get the vertices. But it's inside of the curve geometry that they have this functionality to update attributes. And yeah, so I'm gonna step over and see what happens. I'm gonna go quickly because all this stuff related to seeing layers is not related to the stuff that I'm trying to do. So I'm gonna go quickly and just show this stuff, because I already went through this one a bunch of times. The one that I didn't went through a bunch of times is the depth. What happens after we add the depth, and that's the part where it's gonna actually use the first initial data for the points, which are just 3 points that it gets to create a basic curve in the beginning. And then there's some parts that is a bunch of stuff related to bevel, which is the way that they call the attributes of the curve. And that's the stuff that is actually going to take the curve and is going to create the vertices. And the vertices is the thing that I need. So is your end goal to work in tech, or this is simply a hobby? I'm not going to talk about this stuff, man. It's just personal, and it doesn't matter. I don't think it's a good idea to talk about your personal life on the internet. If you have anything related to business, I have my email on my account. You can just email me. But I'm not gonna be talking about what I want you to do, this kind of stuff. No, thank you, man. This RNA stuff is also related to it's not memory management, it's just like managing the state. So basically they do everything based on RNAs and DNAs. And DNA, I think, is I'm not really sure if it's the essence of the object. But RNA is probably like, an analogy to the entity component system would be that the RNA is the components and the DNA is the entity. So RNAs are like properties, and they use the generic functions, I think, to, based on whatever type you have there of the object and this kind of stuff, it's gonna add different properties to the object, because they're always using the same object structure. Sure. So it doesn't work with inheritance. It works with composition. And there is stuff on the documentation that they talk about that they are trying to move more to object-oriented approach, because it seems that it's better for scaling, but I'm not really sure. I know that either on the documentation or some videos that I've seen, there's some stuff related to that. So I'm just gonna skip these functions, spreads of 10 and everything. And I do think it is worth, like the way that I'm doing things here, I think it is worth to do it, because initially I was gonna do it in a way that I was copying everything. Like I said on previous streams, I think my idea was to copy everything, to keep the same folder structure that I use on Blender, because then later on I will be able to move more stuff from Blender to the stuff that I'm doing there. But then I thought about it. I had a previous experience of trying to move the 3PP library, which is a C++ version of 3JS, and I was trying to implement my own way. So copy everything from the library and then changed, which is basically what I'm trying to do here. And then I remember that I kind of regretted spending a bunch of time on like just copying all the functions, and what I should have done previously, and looking back at it, is the thing that I'm trying to do here now, which is just to look exactly for what you want and then try to extract that. But then obviously that's the line that is kind of hard to figure out, because in one way you can copy everything and then figure out what you want later and then remove. And in another way you can just copy line by line of what you want, but then it's very inefficient because it's not fast enough. So the challenge is always to find the middle way. So what exactly is the stuff that I want? And usually, I think in these kinds of situations, it's going to come down to being able to remove the state of the application, because the state is the main thing that is going to be different from application to application. And I think that's the more differences you have in the gradient of composition to object-oriented, the harder it's going to be to make the transition, because obviously the state changes a lot. And that's, I think, where the most gravitational force of the thing is going to be, because everything compounds on itself, like the bureaucracy. It's like the same way that companies works and everything like that. Like the more you add on top of the thing, the harder it becomes to change, because everything starts to couple with everything else. So I find, at least for now, that's what I'm trying to do, is to just like focus on the functions that you want, then copy the functions, remove only what's necessary or change only what's necessary to have the inputs and outputs of the functions in congruence with the other stuff, or in the generic ways that allows you to implement the function on any framework. So basically change the functions by changing either the arguments. It's basically inputs and outputs like everything else. Then once you get to the point, then you can test, and then after that you iterate over the smaller parts of the thing that you have. So it's like you're creating a funnel to filter the information to translate into the other one. And I think the way that I'm setting things up is probably going to be good. I don't think I'm going to spend a bunch of time trying to translate other things from Blender, because that's the kind of the downside and the place where there is nuance, because if I want to build something in a systematic way that is going to allow me to translate a bunch of stuff from Blender to the thing, it makes sense to think about how the translation of the management of state is going to be. And that's the part that is kind of hard. But I think that part is like, it's not worth it for me right now to try to change that part so that I have like a state management that is congruent with Blender, but at the same time uses Godot stuff, because I think that's is not worth it to the stuff that I'm doing now. So it makes more sense to just focus on translating the curve and then getting the curve in the way that I'm doing. And since I went through this process of studying how the curve works, my understanding of Blender is already much better. So if I want to translate something else, I'm going to have to do the same process, I think, and then just settle for not having like a way to easily translate the state from Blender. But I think it's fine, because as long as you know how to draw the line and to cut the stuff that is related to state from the stuff that is related to vertices, it should be easier next time to translate. Because the hard part here is going to be also if it doesn't work there in the end. So if I translate everything and then I draw, and like the worst part is going to be not if there's a compilation error, but if everything works fine and then it just draws the stuff in the wrong way. Because that's the most annoying thing to figure out. It's like because there's a bunch of functions here that are kind of annoying as well. And the functions that are annoying are the ones that are related to drawing the vertices. Because basically, and also there's some stuff on the documentation, some reference that they put there, which remind me of the mathematics behind this, which is just topology, basically. So it's the study of surfaces, and obviously it goes very deep. So, but I'm not really sure if it's worth to dive into this right now. But I think I'm gonna have to anyway at some point, because obviously it gives you a lot of power if you're able to think about how to draw everything from vertices and from triangles. So that's the fundamental of the stuff that I'm doing now. I think that's probably more important than just drawing one specific shape. You're just understanding the fundamental, how everything is drawn. So how to convert. Because the hardest part here, and the reason why I contemplated as well, and maybe I'm gonna try to do that if it doesn't work here, which is just to, it doesn't seem that hard. The hardest part of drawing a curve in 3D is the rotation you have to do on. So it's figuring out how to do the rotation. But like what I could try to do, if I want like the easiest way possible, like the brute force solution, let's say, it would be to just draw a circle, which is you just use sine or cosine to do the rotation of the points. So you draw a circle with a bunch of triangles. Then from that circle, you just iterate, and then you follow the path of the Bezier curve. So follow the points that I have there. Then you have another function. The function takes input and outputs, and then based on the amount of control points you want, it just uses the equation for creating the Bezier curve to draw the points in 3D. Then from those points, you draw the circle and then loop over, and then just draw circles from one point to the other. The problem is I'm not really sure if the curves would be good. And this is this stuff. And the other thing that I'm not really sure is that if you do it this way, it might be suboptimal because you're drawing like a thick curve. And if the purpose is only to see the curve from the outside, then it doesn't make sense to put triangles on the inside, I think. It makes more sense to create a surface out of triangles. And when you think about creating surfaces with triangles, it becomes very hard to think about. So this is kind of the stuff that I'm not really sure if I'm going to study now. Topology to try to understand how usually the fundamentals of drawing surfaces, curved surfaces with triangles. This is basically some stuff related to the threads that they use. And they're just using these functions to allocate in free memory. If I remember correctly, still not the points where the main function is gonna happen there. I might have missed. No, I think it's this one. This is the first time that they're gonna initialize the curve, I think. So they're initializing the object here. I think probably here. So there, I think it depends on the type there. Maybe it's another function. But I do remember, yeah, it's this function here. So it wasn't the one that I was going over. But this function here, it gets called there at some point. And then based on the type of the object, it's going to call these different functions here. And those functions are the ones that actually create the points in the beginning. And it's very simple, the points. Just 3 points, and then it changes the position there, obviously. What is not simple and it's kind of annoying also always is to remove all the stuff, like I said before, related to the state management of the thing. So that's the hard parts of doing this, I think. Understand the relationship between everything. Here, basically, it's gonna go over these ones because the type's not either this or that. So it just initializes these values here, and then on other parts, is gonna call after it creates the initial values here, it's gonna call another function passing the object, or another function that is either gonna pass the object or call a function to get the object. Then from the object, it gets the curve from the data attributes of the data member variable of the object. Then from the curve, it's gonna access the NURBS thing, and then it's gonna create the best triple. And then it's gonna use that to do everything. So basically here. So I'm just going to skip, just F10, goes here. There's also some calculation here to move the, which also I'm not going to do because I'm only interested on the local coordinates of the object, which are basically the coordinates that create the geometry. So the local coordinates is the coordinate system that you use to build the geometry of the object. And then for positioning that object into the world coordinates, you're gonna multiply by the world coordinates, or you multiply by the local matrix, which keeps the state of the local coordinates, and then you transfer to the world coordinates. But it's basically the reason why you use two different coordinate systems is that it makes it easier to translate or change a state. So you have different reference frames, but it's basically the same. And then here, there are some calculations to change the curve based on the world coordinates reference frames. And some other stuff to create the points on the local coordinates, which is the best triple, whatever. Yeah, pretty much. No, obviously not. Someone's asking if I say this stuff out loud when I'm not live streaming. I'm just explaining what I'm doing, obviously, because I think that has value. So, and the way that I'm imagining is that, and it feels kind of weird because now there's a bunch of people watching, but I've streamed a lot of time without people watching, and it is like the way that I think about it is more that I know that, so, like, if I keep going, then it's unlikely to fail because obviously you learn and become better, and then eventually someone's gonna go through the same problems that I went through, and then they're gonna be able to see what it's actually like to go through the path of learning. So it makes a lot of sense to just explain what I'm doing. And I think it's a win-win, obviously, because it obviously increases the chances for me that things are gonna go right. The more people I have watching, like the higher probability that I'm gonna get opportunities and open doors and stuff like that. And people gain the benefits of being able to see what it's actually like to build stuff. And I had this, like, it's really crazy how your mind changes the more you try to build stuff. You become a lot more grateful for everything because I think it's very common for people to take everything for granted nowadays because of so much, the amount of stuff that we have. When you go to a website, like the natural instinct is to always complain about it because they're so used to like having high quality stuff that you don't realize the amount of work that it actually takes to build things. And then like you're comparing everything based on a standard that is insane because like a lot of these websites, even though they seem simple, like YouTube, if you think about it, like the amount of work that actually goes into building this kind of stuff is insane. And most people don't understand that because you're used to using this kind of stuff all the time. So you don't think about all the actual data, the politics, everything that's goes on behind the scenes to create this. And this is the reason why, like, and I think it's just human nature. Like, it's very easy to complain about everything, but if you put yourself in the position of someone that is actually trying to build stuff, like people that own the websites, and you think about all the complexity behind the scenes, like the proxy wars, the actual wars, everything that is going on, to like the culture of the company, everything. It really makes you think, like, and be more grateful for everything you have. I think that this is another benefit here. Like, if I'm able to build something, and people are actually gonna be like, they're gonna see the whole process of what it actually takes. Especially, like the more, like I said, the more I do stuff, like you don't realize how hard it is actually to just draw a simple circle on the screen, and how much work actually took, like for all the people involved throughout history, to come up with all the innovation and all the complexity behind everything. It's like absolutely insane. Let's keep this stuff. I don't really know for sure what layers are. There is some stuff on the documentation that talks about it, but I'm not really sure uh, like exactly what the purpose of the layer is. Obviously, it has something to do with the objects. I think in Godot has layers as well, but I'm not. I have to review this more. But I know that it's not related to the vertices. It might be related, but not in a meaningful way, I think. It's possible to just get the vertices and not worry about the layers. As far as I've seen from the functions here. I'm just gonna. This is the first time, I think. So this is gonna do the. Is gonna this functions here. The purpose is to change the state of the matrix of the object. So it's changing the world coordinates, I think. Maybe it's local coordinates, but it is the local coordinates of the object, not the curve. It's just doing matrices calculations. So the matrix holds the state for each thing because it's easier to put on the matrix. So the way that I think about it is that matrix is a reference frame, is a relative coordinate system. And the world matrix is going to be the one that it is like another reference frame, relative reference frame, but because it is the denominator, the common denominator between all of the other other reference frames, it works to keep track of the state of the whole thing. But if you think about it, just like in physics or life, there isn't really like a common denominator. The world coordinates are determined by the state of the tree, which is the relationship between objects, where everything is relevant, relative. So this is how I think about physics as well. Like there isn't an absolute objective reality, let's say. Like there is, but it's always the objective reality is the synchronicity of the relativity of the network of different reference frames that have that common denominator. That's basically what's happening, I think, here. So I think this, no, this is the, yeah, it's right after this one. So this one I think is still just doing calculations to change the states of the world or of the local card. Not really sure if it's local, like I said. So it's probably, so it's going through from the local coordinates of the object to the world coordinates, I think. That's why it's doing these calculations here. Just based on this thing here alone. And then after this, I think this is the first, yeah, this is the function there. I copied most of the stuff there. And the thing that I changed, which is also kind of annoying as well, is that here they're using floats. So this part I'm not 100% sure. I'm gonna have to see when I try to build, because I think that they use, like there's some situations where they use floats and they use these floats like arrays. So here's basically creating an array of 3 floats. And then sometimes they allocate memory for the floats, but that's not how Godot does things. So in Godot, as far as I understand, I mean, I guess you can do that, but it wouldn't work in the way that it's supposed to work. So in Godot, you have memnew, which is a macro that they created to allow you to allocate memory in a memory pool that they create. So it's basically using another version of mem or of malloc that is from a kernel library that allows you, and then they use a string operator before the new operator to allow them to place the memory into the memory pool instead of using the normal standard way that C++ or C works, which, as far as I understand, when you use malloc or calloc, is going to allocate memory on whatever parts of the computer. There isn't it's not going to put on a linear way, which makes things less optimized, I think. So that's the reason why they use a memory pool. And every time that you create an object, you usually use the memnew macro to allocate memory because you want to have all the data that the process is going to use, which is the Godot process, into the memory pool. But I haven't seen, I think, they use this stuff for floats, and I think it wouldn't work because you would only allocate memory for one float, because usually the way you do it is by passing the class. So this stuff I'm not 100% sure, because here they do use calloc or malloc, but they don't put only the float, they put the size of the whole float. So it's like allocating memory in an array that is going to receive. Each block of the memory is going to be the size of the float. That's how I think calloc and malloc works. So right now I changed for vector tree, I think. So instead of using float array of floats, I'm using vector tree. And I'm gonna have, this is another part that probably one of the main parts that I'm not sure so far, because here on the best triple there, the data structure that they use to keep track of the points is not really, initially I thought that it was a, because I was looking through all the other stuff, that it was a vector of 3 as well, which in my mind it would hold only the data for 1 point. But it seems that is a matrix, a 3x3 matrix, so I think it's supposed to hold the 3 points of the initial curve, and then each best triple is supposed to hold the information for multiple different, or for one curve. So each one holds information for one curve, which is just 3 points. And then if you want to put more points, it probably creates another base triple and maybe interpolates some of the points. But this stuff I'm not 100% sure. But here in the way that they do it is they don't use this basis here. The basis I'm using from Godot, which is the closest thing that I found to a 3x3 matrix. And Godot doesn't use this normal matrix. They use Transform 3D as well. So Transform 3D is their version of the 4x4 matrix that you usually need. And the reason why it's 4x4 is because of homogeneous coordinates. So this is another thing that is very confusing. I was very confused when I started learning about rendering stuff. But the reason why, so usually, if you think about drawing stuff on 3D, It's going to be three values, obviously, one x, y, and z. So the reason why you need a 4x4 matrix is because it allows you to hold state for translation. So if you want to translate, it's basically going to be a multiplication between different matrices. And if you only had a 3x3 matrix, it would override the values of the positions of the matrix every time you translate. So you basically have another row or another column, depending on the standard of the framework, that is going to allow you to keep track of the transformations that were done on that local coordinate system. That's basically why you need 4x4, and the name of this is homogeneous coordinates. And it's also because it holds the state for, it allows you to do perspective projection, because it works as it keeps track of the z, I think, that the z is going to be the stuff that it gives you the 3D illusion, which is basically dividing the coordinates of x and y by z. And that gives the perspective projection. So the w coordinates, the w value, which is the fourth value of the matrix, is the one that is used to divide the coordinates. So a 4x4 matrix allows you to hold the state, to keep track of that transformation on the matrix. So here they use transform 3D class as well. And as far as I understand, it's 4x4 because I think it's a combination of the origin with the basis, but I'm not 100% sure. So basically, basis is 3x3, then you add origin, becomes 4. But not 100% sure. It's kind of confusing. It is compiling, obviously, but we'll see if it works. And basically here is a lot simpler than it seems. Like basically all these other calculations here, they don't have anything directly to do with the, as far as I understand, it's different calculations for different types of curves that you have here. Or also there's another thing here that I'm not 100% sure, but I think that's how it works now. So you have this H1 and H2. And initially I thought that this would be the control points of the curve, but now I think that they are related to the two different lines that they use on the curve that allow you to edit the curve. So not directly related to the curve, it's just other lines used to allow you to change the state of and shape of the curve. So I think that this calculation here, this function is more related to the handles they call, and not the 3 initial points. The 3 initial points is very easy, just gonna multiply by grid, and it's just gonna be 3 different values. 3 different vectors, vector 3, which creates the initial curve there that they have. But this part's kind of confusing as well, but I think I can just ignore, like I said, because it's just related to the handles, not the actual thing. But it is kind of confusing because they use these 3 different points here. And I think I think that they create a linked list with this, but I'm not 100% sure how it works. And this is another part that was confused, and I think I solved this now, but I'm not 100% sure again. But that's how I think it works, is that initially I was thinking, where does this P2 come from? Because usually when it is a macro is like this, there's another macro defined somewhere that is going to define the P2 value. But here, as far as I understand now, this is not the P2 value. So when you press F12 on VS Code, it goes to the definition of the thing. So when I press F12 here, it goes here, but sometimes this stuff happens where it goes to the wrong place because it can't find. So I think this is one of the situations where this is not the P2 that is using here. What's happening here is just that it's defining the macro like this, and then at the moment you use the macro, it's going to replace P2. So I think the P2 that is using here is this one. So it's basically just, and the reason why it does like this, as far as I understand, is that because they're using a vector of floats, it's just a float pointer, it is like a vector of floats, because that's how a string works as well. So a string is just a char, which is just going to be a pointer to a character. So that character is going to be the beginning of the memory allocated for the string. And it's kind of like you're creating an array where each slot of the array is going to have the size of a char. That's how strings are created on C. And it's the same thing here for the floats pointer. So all these points here are just a pointer to the initial place in memory where there's going to be an array of floats. And they do it like this because I think it's easier to create 2 different vectors like this. So it's basically just creating 2 different vectors of 3 positions where the P2 place in memory is going to be the middle of the vector. So this creates two different vectors where they're going to be handles for P2, I think. And that's what this function here is mainly doing. It's changing the value of P2 underscore H2 and P2 underscore H1, which are made out of these P2 points. So it creates the handles based on the P2 value in memory, creating two different arrays of floats. But it's still kind of confusing to me. Because it doesn't seem to use this outside, or like it doesn't return anything, so. But it might be because you have the place in memory the P2 is at. That's, even though you don't use here, you're gonna use later on because you have the values in memory. But it doesn't matter that much, like I said. I'm gonna try to do it without this thing. And my stuff there also, I didn't copy this stuff here because the macro is very annoying to pass. I tried to translate there, but it didn't work. And this is a variadic macro. So it makes sense here when you read the code and go to the definitions, but I was getting some problems on the other one because it wasn't pasting the name. So they use the token paste operator. And I think it's related to other stuff that is probably on other parts of the code. And that's the annoying thing. So I'm just trying to avoid using that because based on the, if you step over, it's not going to go over for the case that I'm analyzing here, it's not going to call anything inside of this macro. So inside of the conditions. So I just decided to remove. But it's basically going to paste these tokens here and create another name using this X and Y thing here and this count here. And ChatGPT says that is a condition to see if you have something inside of an array. Yeah. So it's checking to see if the first name, I think, exists on the array, which is the second value you pass there. Yeah, and so it's basically checking the numbers, I think. And the numbers are going to be the enums that it puts there inside of the thing. This should just make the first values as identity matrices, the ones that initializes here. The other ones doesn't matter as well. It's a flag. So it's initializing the memory for the no resolution. So this is the part, the only part that matters. So they have on the not documentation, the comments there as well. But it's basically this vac here inside of this base triple, however you say that. It's just three different vectors, I think. So at three different points. And it's based on the first index there. And this grid, it's initializes here is just going to be 1. It's just creating three different points, which is the initial curve there. And that's pretty much all you need to create the first curve there. But obviously this stuff matters for understanding the rest of the things there, the states. So here is changing as well, but you can see on the, hey man, what's up? Let me go to the definition. So here they explain location of handle. This part I'm not 100% sure as well because it's saying handle there, so I'm not really sure if it's the point. But I think this one, these are the points, I'm pretty sure, that it is going to use to create the curve in the beginning there. So this is the first point that it has there, then the 2 is the final points, and the other one is the control points, which is the point in the middle. And Bezier curves are basically that. It's just an interpolation of two different points that allows you to get another point in the middle that is going to create an equation. And then you can use that equation for a bunch of things, obviously. I'm trying to translate the Bezier curve to, someone asked what I'm doing. So I'm trying to translate the Bezier curve from Blender to Godot. So get the information that they use to create the vertices, to create a 3D curve, so that I can use the same vertices on Godot to draw line 3D. Oh, so this is the handle type. Yeah, whatever. Like I said, I'm just gonna copy everything and then see if it works. Then if it doesn't work, you just keep iterating until I'm able to do it. But I'm gonna assume now that the thing that I'm thinking is correct, which I think it is. So the vac is the main thing that matters there inside the best tree. The best tree is inside of the null. And it's just gonna be the three positions there in the beginning. I'm just gonna go fast over this. This doesn't matter. So calculates everything. And then this part, it still doesn't have anything to do with the curve, but it does. This is gonna return 0 here for this thing. Just return there. So the main thing that I think it matters from this part is the null, then the best triple here. And these are the values. The vac here are the values of the three vectors in the beginning. So it's just changing the position of x and y, and it creates the point at the beginning there, as far as I understand. And this is the stuff that matters. So the challenge is to figure out how this is related to the vertices. Because obviously, I think, yeah, but it's kind of hard to parse because there's a bunch of stuff that is related to just managing these states. So I'm not really sure. So basically here is the point that it connects. So this edit nerb here is gonna, this thing is so it's a linked list. The list base class is a linked list. And it's basically putting the null at the tail of the linked list that is the edit nerbs here. And the edit nerbs come from the object, which comes from the curve. So from the object, you get the data is the curve. The curve has the edit nerb, which as far as I understand now is not initialized in the beginning. So this is just null values with empty pointers in the beginning. After it initializes the nerbs, the first nerb that it uses there, then is going to be the address of these nerbs here. But the values of this edit nerb is just null, I think. And then this nerbs is going to be a linked list that contains the nerb structure. So this is the part is very confusing, and I think it's because of the state management of everything. But for my case, I don't think I need this because I'm thinking about it in a different way. So, which is the kind of annoying and difficult part to do it, but yeah. Basically, the way that I'm thinking about it is extract everything to create one simple curve, then clean up all the states related stuff, creating only one function with inputs and outputs that depends on the range of the points. Then get the logic to add another control point and see how that works, and then put that logic inside of the function as well, and basically make a gradient where you pass the beginning and end of a curve. You pass 2 points, the beginning and end, and then you pass the amount of control points you want from those points, and then all the logic is on the function. But I think obviously they do it this way here because Blender is different. So the purpose in Blender is to be able to manipulate the object in several different ways and combine with other stuff. But this part is the stuff that I was talking about, the mentality, let's say, of the whole framework is going to clash with Godot because they're using 2 different paradigms because they have 2 different purposes. So the challenge is to find the line between the 2. That from the states for the stuff that matters. Because obviously in Godot, if I want to do something similar, I'm going to have to eventually incorporate this stuff as well that they do on Blender. But from that point, I think it makes more sense to incorporate this stuff on the outside classes that are going to use the curve to begin with. Because the other stuff, Godot already has a bunch of stuff for calculating positions and stuff like that. But it's going to change fundamentally how it works, I think. I don't think I'm going to be able to find based on the data here. Or the objects on it. It's just a pointer. C is the contacts. Oh, so this is what I was talking about. So the edited NURB seem to be just empty values at first. Like it doesn't initialize the edit NURB anywhere, but it does point to the NURBs. There's basically this structure here. So it does initialize these parts, but it doesn't initialize the edit NURBs stuff there. And then this is the linked list, the NURBs. The values here are empty pointers, but they're gonna be pointers to the NURB data structure. There's a linked list of NURBs. And the NURB is the thing that contains the states contains the actual points. So I think each NURB is one curve, I think. And then the other one, because it's gonna use the curves data structure to keep track of all the curves. So I think for the main, so the only other part from this cycle of adding the curve there, the only part that matters is that at some point it's gonna call the function there to copy the curve from the old way that they were doing, which is the way that it is now, that I show now, which is the curve data structure. They're gonna take that curve data structure that they initialized and they're gonna translate it into the curves data structure. The curves data structure is the data structure that has the curves geometry, which has a bunch of stuff related to reading and writing attributes, which is the stuff that I didn't copy yet because I don't think I'm gonna try to avoid using it, because that data structure is coupled with a bunch of other stuff that they use to manipulate memory. I'm gonna parse of F10 on everything because I'm pretty sure I put breakpoints there, so it's probably gonna go to the function. If it doesn't go, it doesn't matter anyway, because I think it calls the function again at some points on the other parts where the functions that are going to be called after you change the DAP. So I think it's going to be somewhere here. So is this, I think. So first it reads the curve from the edit NURB, or gets from this NURB. I think this NURB, this part I'm not 100% sure. Yeah, but I'm pretty sure that the NURB here, so there's two different NURBs. One is directly on the curve, and the other one is inside of the edit NURB. So I'm pretty sure that initializes the one. It puts the, so this is the thing. From curves, you have the edit NURB, and then from the edit NURB, you're gonna have the NURBs. And then it puts the NURB as on the tail of the NURBs from that path, on the thing that I showed there. But it's also gonna put that NURB inside of the curve directly. So I think that's what's happening here. So this NURB here is the same one that exists at the tail of the curve, edit NURBs, and then you have NURB at the tail. So it's basically the main data structure used to keep track of the points. But it is kind of confusing there, the way that they do it. And then they use that to duplicate and pass to the other stuff. Just gonna add to the tail again. Also, I think this function is probably related to depth as well. So bevel, as far as I understand, is the stuff related to either extruding the curve or adding depth, which is the stuff that creates the actual line 3D. So I have to understand how this is the part that I'm trying to clarify now, which is going to use these other data structures here, this bev list, and I have to see how I'm going to copy this. But I'm pretty sure here. So this is another weird thing that I don't understand very well, how they do this or why they do this, but usually that's how they do it. So they create these different names here that are pointers, and then they make the pointers equal to the other data structure. And then they change the pointer. But effectively, I think it's doing the same thing, because when you change the value of the pointer and the pointer is pointed to another pointer that points somewhere, you're going to change the value of where the last pointer is pointing to, if that makes sense. So, for example, let's say that the type is the same. I know it isn't, but the type of this is the same type of this. So if you make this pointer equal to this one, you would point to the same location in memory. So when you change the value of this, you're going to change the value of the other one, because they're pointing to the same place. But I'm not 100% sure. I think that's how it is working here, because that is the only thing that makes sense. I think that's what they do here, both with this stuff here and this stuff. So this one is not, I think the first time that you do it is not cached, so it doesn't have anything here. But that's on purpose. So they just initialize this and make equal to this, because next time it's going to be cached. But they're going to use this bev here to call on the other functions that are going to actually build the vertices, I think. But on this first part, I do think that they use the same functions, but the only difference is that the first time you initialize, the values are 0 of the depth. And I think it does have some extra value as well, but they probably use on the calculations here. So it checks to see all it. So it's adding this BL to the endpoint of this thing that is the thing that is it gets from the cache value there of the curves. So curve cache. As you can see here, it doesn't have anything. No, it's this one actually. It's just empty, but it does have a value in memory because it's the one that's cached there. And then it's gonna put this other structure here. And I think it's the same logic from the first one, where this one would be the list of NURBs and the other one would be the NURB. So it's just putting the stuff that actually is going to contain the points or the information for the points, and the end of the linked list that keeps track of the state. So this stuff keeps track of the state, this stuff keeps track of the points, which is this value here that allocates memory for. And there's 2 different types of values as well, which I don't remember really well. I don't understand what you mean by that. Oh, pretty hard coded. So I was going to show this thing here. So it's the same value here. There's the same thing in the beginning. And then it's going to put there. And then updates the value there. So this is the part that I was talking about. I don't understand why they do it like this, but yeah. So I don't remember initialize this here. So it creates this pointer here in the beginning, and then all that is going to do is just going to initialize that pointer. It's probably because of the control flow. So I imagine that, because I didn't look into this very in depth yet, but because there are different types of curves, it probably changes the values along the way. So that's probably the reason why they create another pointer there. Now, depending on the control flow, the value of this pointer is going to change in a different way. And so you need to decouple from the previous data structure, which is this one. And this one was the NURBs that initialized there in the beginning. Just best triple. So it's just looping over. And I think it passes this to the function. Yeah. So this contains all the, is a list of NURBs, of NURB structures. And it only has one because that's how it works there on initialization. So the no is the one that it was initialized in the beginning there, which is going to contain the points on its value here. And then it's basically making this pointer point to the same value in memory that this stuff is at. What does this Blender's Bezier curve exactly do? It creates a Bezier curve in 3D. That's basically what it's doing. A Bezier curve is just a curve. It's an equation you create. So you take two different points, and then you interpolate the values of the points somewhere along the curve. Interpolating just means that you take the distance from the point. So imagine you have a source and target. You take the distance from one point to the source and its distance from the target, and then you divide the two, as far as I understand now. When you do that, you're interpolating the point. That is somewhere along the line, along the curve. Then from that, you create a mathematical equation that allows you to create the position of the curve. So depending on the amounts of, for each point in the middle, you are along the line, along the curve, you create these equations, and then the final equation is just going to be the collection of the points, which is a polynomial equation that represents a curve in 3 dimensions. You can represent in 2 as well, but I'm doing for 3 here. Then based on that, you can draw curves in 3D. But the hard part is that after you have the curve, if you want the curve to have thickness and to have depth, then because you need that in order to create something that is going to show up on the visualizations, because everything is drawn based on triangles. So if you want to have that, you need to do some stuff that I don't understand yet, but it's basically going to create vertices, create triangles from the initial points that you created in the beginning. So the initial points is just a curve in 3D. After it has that, it creates vertices out of those points, the location of the curve, to draw the actual thing. So this, I think this is one of the main functions that I'm probably gonna, I think maybe I already copied this one. Yeah, I copied this one already because it doesn't have too many, like it doesn't have things that, the only thing that it has is the macro here, which I'm probably gonna have to change because it's one of those things that is a point show floats. But I think this one is one of the main things that is gonna use to get the data there. So for diff Bezier. And there's another one that is the tilts. So I think these are the main functions. So for each point here, it's just for each curve, it's just three points. It's gonna loop over, and then it's gonna calculate these values here. And this is probably gonna be the thing that it uses to create the depth. It seems complex, but it's just like, yeah, it depends on how you look at it. It is. Yeah, but the more I learn, the more I think about these things. Like, everything can be broken down because reality is fractal. So there isn't anything that is easy or hard. It's always relative to the place you're at the moment in time. And usually because of human beings' nature, we tend to compare ourselves with each other and not look at the absolute perspective. So that makes you think something is hard or easy. But if you think about it, you can always break everything down into smaller parts, and then you're just building on top of that knowledge. Then eventually it becomes easy. Because obviously, yeah, it is hard because you're just accumulating more information, but it just means it's going to take more time to download the data in your subconscious mind. So this part here, yeah, so here, I think these two here are the vectors. So I think that it is like the description was saying there in the beginning. The first index is going to be related to the what kind of point it is. So here is taking the origin point, which is the 0, which calls first handle, or yeah, handle 1. And then the 1 is the control point somewhere along the curve. And then here is going to depend on the index of this. So the j here is probably x, y, z that is doing. So it's probably using this in comparison with this one to create depth, I think. But I don't understand this part very well. This one is the... So there's also different types of curves. The one that I'm looking at, I think, is not the cyclic. I think the cyclic creates a circle at the beginning. But I think the one that I'm looking at is this one. So it's probably going to be on the else here. So this initially is like this, which is the one that is used there in the beginning. Yeah, I'm pretty sure that this is the points I'm at here. So in the beginning, this previous, so it's just keeping track of the previous Bezier point. Because in the beginning, they're the same. Oh, so it just is creating like, is moving the pointer. So because this best t here is a pointer, when you do plus plus, it's just pointer arithmetic. So the way that it works under the hood, as far as I remember, is that pointers have types, and the type allows the compiler to understand the size of memory that the pointer is pointing to. So every time you allocate memory using malloc, calloc, or some variation of that, what you're saying is that you're gonna have a space in memory that is reserved for the thing that you're allocating for, which is gonna be the size you put as you create the malloc or calloc. So the compiler is gonna calculate the size, the overall size of that thing, the data structure, which could be a class or something else. And then that size is gonna be the size in memory that you have. And the type of the pointer is gonna dictate what is the size that the pointer is pointing to, which in most cases is going to be on the beginning of the thing. So when you do plus, you're just pointing to the next index, let's say, that the pointer is pointing to. So I think what is happening here is that it's making the previous Bezier equal to the Bezier at first. And this Bezier here is equal to the new Bezier that is the one that's initialized in the beginning there. So this stuff here contains the information on the vector, on its vec value, related to the 3 points of the curve in the beginning. So this value is going to point to that place in memory, and then is making the previous Bezier equal to that one. So they both point to the same place, and then it is moving the pointer to the right of the best t right here. So I think what this does is that it makes this one point to the beginning of the array, let's say, array of this data structure, and this one points to the next value on the array. But it is kind of confusing. So what is confusing me now is that based on the stuff that I've seen here, it seems that inside of this data structure is going to be like the whole data for the 3 points that make up the curve. So this would be like calculating or keeping track of 2 different curves, if that makes sense. But I'm not 100% sure that's what's going on. So I guess I'm going to look there once this goes out of the function on the value here to see what this points to. So I think it hits this point here. So it doesn't calculate this stuff here because this is not true. So it's going here. So this would be like the first Bezier curve. This is the vector that contains the 3 points. So this is the point in the middle, the control point of the first Bezier curve. This is the final, the target point of the Bezier for the first Bezier curve. And this is the x, y, and z positions. So first it takes x, then y, then z. And then here is for the next curve. So it's probably comparing the 2 different curves. And this is the other data structure they have there to calculate probably the points that are going to be related to the vertices, I think. So this is passing the whole vector in the beginning. So first passes the first point, then the second and the third, and then the resolution. So I think that what this function is doing is just comparing 3 Bezier curves inside of the data structures that they have there. And I think the BAV points related to the vertices because it's probably going to build everything out of quads. I think usually that's how mesh works. So because everything is rendered with triangles, it becomes easier to draw a mesh, creating a rectangle or a square. It's just the collection of 2 triangles, which usually is called a quad. So I think that's why they are saying this thing here. Must stay aligned to 4, so size of Bezier, size of float works. Or maybe not, it's just the size of the float. see when they initialize this. So bev p is gonna point to BL bev points, which is this thing here. And this BL is this thing. So BL is at the tail of bev. I think I'm following so far. Well, in the beginning. So why don't I just see? Doesn't have previous Bezier there. So it seems like these are the points there at the beginning. Also is here. So I wonder what this is. This is the thing that is kind of weird. Because maybe I have to go back to see this. Because it seems that here that it has like 6 points. And then the list there has 2 NURBs. But I don't remember at which point it creates the second one. So maybe I skipped that someplace. It seems that, so maybe I should keep track of this. It might be on those functions that are that copy everything. So I'm gonna write down a question there. But I think that the problem is that the second time that I'm gonna do this is already gonna be from the points that it has. I'm not really sure. But I do think I need to know this before. So here you're just gonna do the same, like it's gonna calculate for the 3 points. So it basically has 2 different curves now, as far as I understand. The first one is the points that initialize there in the beginning from the no NURBS vac, or no NURBS bas tree, bas triple, and then vac, which is this previous bas here. So this is the first 3 points. So, and this is seems to be a second curve that they have, and then this function is just comparing the two. And probably these other ones are going to be like variations of that as well. But I don't remember where initialize this second curve. And here is if you have more curves probably. So just loop over and you move the point. So here is moving the pointers. So yeah. So like it's iterating through the linked list of the best triples that are inside the NURBS in the beginning. And for each one, it calculates the differences in the curves. So I'm just gonna, yeah, I'm probably gonna have, so question I have is, where does it initialize the second? On the NURBS. As on no. So I think that no has this no here. It's gonna be a NURB. So on the NURB you have probably, because this is a pointer, this is not one value. So it's like I said before, it's like the pointer of this type here, which means it's gonna create an array of these types here. So every time you do a plus plus on this value, is moving the pointer through the array. So it's like iterating over an array that has this type here. So the weird part is that in the beginning, it seems that you only initialize one value for this, but it has 2 there. So at some point initialize the other curve, but I didn't see where. And this one is the one that's going to contain the points on this matrix. So I'm gonna, I'm not really sure what should do. I think I'm gonna go very fast over the depth stuff, the depth part. Then once I go over once the depth, I go back to the beginning and I go over the ads again to figure out. Because I wanna, so I'm gonna go one time over the depth parts of the thing and write down the functions that they use. Probably gonna use Scaled Radar. So there's two different parts. One is writing down the functions, the other one is keeping track of the relationship between the structs that are related. To figure out how the first part is connected to the second part. And I think it's kind of clear already. But I'm gonna write down here probably. So from the moment you change the depth, what happens to create the actual vertices? And how is the first data structures from the first part used on the second one? And after I do that, I come back and try to figure out at what moments is gonna add the other points to the nerves there. But I do think that these functions here are also run when you add the depth. Yeah, it's probably this function here, because I do remember seeing that on the other parts as well. So I have 2 points, is this one. So this is probably the thing that makes the depth using this bevel. And this BL is probably the one that initializes the beginning there of points. Blah, blah, blah. I think what these functions are doing is just creating quads or I think pretty sure triangles. Obviously, I'm not sure if they create quads. Should take into account rotation because it's back to quads. So it's quaternion. Changing the vector to quaternion, but I'm not really sure how it does the curve. How does it assign? But yeah, like I said in the beginning, I think it makes a lot more sense to just copy everything. Like just a process of it's like anything is gonna be a cycle, so it's just a frequency. And yeah, it's better to like go brute force first, then you put everything on one place. Like you remove all this stuff, only keep the stuff that is necessary from Blender, puts on the other files. Then once you get to the point and you test to see if it works, then you iterate over and over again to clean up everything and then just keep the functions that are necessary to create the vertices. And once you get to that point, then it becomes a lot easier to understand the calculations, so the specifics of each thing here. So it's normalizing the angle to quaternion. Obviously, I'm not sure how, but yeah. So it seems that it's similar to the other stuff. It just takes the current in the previous on a linked list and then calculates some difference between them. So imagine what is happening is just doing the, so on the rasterization functions, there is I forgot the name of the function, but it's basically how the rasterizer works. It just takes, the reason why it's triangles is because it takes the different positions of the 3 points that make up the triangle. And then for each pixel in between that position is gonna do the interpolation. So it's basically the same logic. You interpolate the values and then you get the actual value of the pixel, the color, for example, based on the relationship between the distances from the source and the target point and the current point of the pixel. And then you have the edge function, I think is the name, that uses the barycentric coordinate of the triangle to figure out whether or not one triangle is on top of the other one. And like the combination of both of these things creates the color of the pixel, if I remember correctly. So I think that it's pretty much the same logic that they are doing here. They are interpolating the 2 different points, and then based on this interpolation, it calls these functions here to actually get the how much the how much you should create like a curvature on the way. So it's basically updating the state of the continuum based on this, I think. And it does that through this linked list method here. But I'm not 100% sure. So the thing to clarify is why there's two different curves. And when did they initialize the first curve? Because here it seems that they are comparing the points in these two different curves. I'll be right back. See how long. 1 hour and a half. I think I'm gonna stop soon. So I'm probably gonna. Yeah, it's probably worth to stop now after I reach the end of this cycle here. Then take a break off stream and then I come back and the rest of the stream I do it from the other part. I might have to run this again from the beginning so that I try to capture where the first or the second curve is created. Because I do think that this is very important to understand. Where do I learn? I can't see the last. Bro, where do I learn? What do you mean? Basics C++. Where do you learn C++? Programming or? So I always recommend to people. So obviously, I learned a lot about this, like since the point I started. So usually, I'm thinking about creating a system to tell people. Maybe I'll do a stream some point. I already did a stream about this, but I think it was too theoretical and not very practical. So I'm thinking about creating or streaming another time, and just making it more practical. But basically, if you go to my channel and you put how to learn anything, is a stream that I did trying to talk about, because it's much more important than like understand the fundamental of how your mind works, both on the psychology and on the physics of things is very important, because a lot of the times is a lot more psychological than it is physical. And it's very analogous to like going to the gym and nutrition, this kind of stuff, which is something that I really don't like. Like when you go to a nutritionist, the most tendency is to always focus on like what kind of foods you should eat, but people completely ignore the psychological part, which is why you're eating the way you're eating in the first place. And I think that's a lot of times this is a lot more important. So on this string, I try to break down the like fundamental principles of what learning is about. So yeah, I would really watch this. So, but I'm gonna try to explain like the surface level how I think about this now. So, like, if you want to learn anything on your own, I think these are the four. There's probably five, and the other one I forgot, but this is the four fundamental principles. So the first one is to have awareness that you don't know what you don't know. So the first part of learning anything is to trying to create a surface level map of the stuff that you don't know. So it's like you're in a forest in the dark and you only have a candle. You're trying to create more fire so that you expand the light and then you become aware of everything that is going on. But obviously, what's the danger behind that is that a lot of the times you don't want to be aware of all the animals that are surrounding you because it's very dangerous. So your mind has protection mechanisms to prevent you from doing that because you can go crazy. So truth is very dangerous, and you should like be careful with that. And like I don't like the whole notion about the red pill as well that people talk about, because like it's not necessarily the case that you should always be trying to expand the knowledge, because sometimes it's like going to the gym and trying to lift a lot more than you can. You're just gonna hurt yourself. So you should take it gradually, but you should keep in mind that what you're trying to do in the beginning is it expands the horizon of your awareness of things, and be okay with yourself if you don't go very far, because it's not about getting somewhere, it's about the journey, not the destination, obviously, like everyone says. And the default state of your psychology is to look at problems and then compare yourself to other people, and then you're going to become demotivated. Because, like, think about money, for example. Like, everyone nowadays is pretty much a billionaire compared to thousands of years ago. Like, you are surrounded by abundance, but you don't think that way because naturally that's not how human beings work. You're always comparing yourself to other people. So the moment you do that, you're gonna look at a problem, you're gonna subconsciously compare yourself to someone that is very good, and then you're not gonna be motivated to solve that. So the natural instinct is to look at a problem and think to yourself, this is too hard, too complex, I can't do it. And then that's how people get into tutorial hell, because they're constantly rationalizing. So what you need to do is to train your awareness so that every time that you get into that state, you remember yourself that you're just looking at too big of a picture. You should break down the problem and focus on the sub-problems that come from that. So immediately after the instinct you have, you should ask yourself, okay, so if this is too hard, how can I break this down into smaller steps? And then naturally you're going to have questions about this. And this forms the exploration of curiosity that is going to drive your knowledge. So you should always start with the end in mind. So ask yourself, why do I want to do this? And what I'm trying to accomplish? And why do I want to accomplish this thing? And this is going to be a cycle, because everything is a cycle. So you need to understand that it's something that you're constantly going to be doing. So asking yourself, where do I want to go and why? And then having awareness over that path. And then as you expand the branch of your knowledge, you're going to ask yourself that again, because you're going to learn and your priorities are going to change. Then every time you're doing that, like, what your mind is going to try to do is going to try to avoid making you take risk and spend energy. So you're constantly going to be trying to rationalize. And the way that you're going to do that is by procrastination. So instead of thinking to yourself, like, I'm going to try to increase the velocity of the cycle of trying something and failing, and then trying again and failing, I'm going to avoid trying because it's more comfortable that way, and I don't have to spend energy. And the reason why you do that is because you're not allowing yourself to rest. So that's why balance is very important. So it's neither this nor that, it's the middle way. So neither you should work extremely hard and you shouldn't not work at all. You should have awareness over like how intense you work, because intensity is much more important. And if you allow yourself to rest and you remove yourself from the outcome and from the end goal, and you allow yourself to break things down, what's going to happen is that it's going to allow you to take more risks and become okay with failure, which is what a lot of people don't want to do. So the more you can become comfortable with making mistakes and being okay with the errors, like the debugging process, the faster the iteration is going to be. The faster the iteration is going to be, the more your subconscious mind is going to be okay with spending energy, because you are also allowing yourself to rest. This is going to increase the frequency of the cycle of learning, which is going to make it, paradoxically, you reach your goals a lot faster, because you're not constantly trying to avoid making mistakes. You're just embracing the process of not knowing, because you're not comparing yourself to anyone else. You're just focused on the process. And this is one of the main reasons why people don't learn. Is not to do with the technical skills, is that they're subconsciously constantly trying to rationalize why they're not taking steps, and because their body doesn't want to spend a lot of energy, and they're not allowing themselves to rest because they're comparing themselves to everyone else. So paradoxically, this leads to them never taking risks, which makes them not act a lot. And yeah, obviously it's very complex, because there's also the relationship between the time you spend doing something and their energy. So it's never going to be obvious if you should learn something or not, and this is why it's so hard. Because I can tell you to learn React or learn C++ or learn whatever, but only you can decide what you need to learn. And whatever you're going to learn, there's always going to be a cost in time and energy that you have to spend to learn that. So the first thing that you have to make sure is to increase your awareness over why you're learning the thing you're learning. And the more importance you think that something has to learn, the more you should be comfortable spending whatever amount of time is necessary to achieve that goal. And then you shouldn't be focused on getting that fast. You should be focusing on increasing the frequency of the cycle. So the intensity of your focus and how in the time that you're able to focus. And always trying to reach the balance between the two. Yeah, that's usually why you struggle, because you're too focused on the outcome and you're comparing yourself to other people and you're also not allowing yourself to rest. So that makes things like blurry because you're mixing pleasure with the work because you're not fully allowing. So like instead of, for example, working 5 hours to try to build something, work for 15 minutes and then make sure that you're really focused on the time. So you should try to have a baseline of that. And then what you're trying to do is just to increase the baseline enough where you get to a point where like you're consistently doing something, at least a little bit a day. And then after that, you go based on your motivation, which is going to fluctuate over time. So you have a baseline of a focused intent you put on something, and that's going to be a lot more powerful. And that's kind of like the whole problem, but it goes too deep, so I'm not going to go into. But basically, like, it's a lot more effective to work 1 hour very intensely than to work 8 hours kind of blurry where you're not really focused. And then the rest is really powerful. So if you fully allow yourself to rest, for example, for 3 hours, and your subconscious mind is going to start understanding that it's okay to spend this energy now because I'm going to be able to rest later, which is going to make you more effective. And this is going to expand the frequency of the cycle because it's going to allow you to take more risk because your mind's going to understand that it's okay to make mistakes because you're going to learn from them and you're going to grow faster. And this is the main fundamental thing to understand. And this is a constant battle because there's always a subconscious part of you that's going to fight against that and is going to have an immediate gut instinct to not try to do things. Which is what you said here, I think, that you look at this stuff and you say like, man, this is extremely complex, which is partially true because your subconscious is never going to tell you a full lie. It's always going to try to grasp on the nuance of the thing because that allows you to rationalize. So there's always a fundamental of truth. Like this is very hard and it is very complex, but however, at the same time, you're just focusing on too much of the bigger picture. So the first thing you should try to do is just break down and then focus on the small parts and make sure that you're always trying to increase the frequency of mistakes you make and becoming better at debugging. And the whole process of becoming better at programming is understanding the debugging process. Debugging is the fundamental thing because through the debugging is going to allow you to expand, because the way that it works is that everyone's going to start at the surface, which is basically React, JavaScript, and this kind of stuff. And what's going to differentiate the person that's very good than the one that is not is how much is the whole ocean that they have of information that backs up the surface concept that they are using to build something. And the debugging process is going to expose how much you don't know about the ocean. And then you're going to have all these responses that I talked about. But what you should be aiming to do is to go from the surface to the bottom of the ocean. And the more capable you are of doing that over and over again, the easier it's going to become, which is going to allow you to gain momentum. Because then every time you face a problem, you have the whole fundamental process behind it, the fundamental principles that are going to allow you to solve things much faster, which is going to tell your subconscious mind that all the effort you put before is worth it, which is going to allow you to generate momentum. So the more times. And this is what you should always be trying to do with your subconscious mind. Always bring awareness to that, because then it allows you to go faster and faster. Not because you're trying to get faster, but because you're embracing failure and the process of doing things. So this is on the psychological side. And on the actual principles of the thing, the most important, so after you don't know what you don't know. So the first part is you don't know what you don't know, which means you should create, you should try to expand the keywords that allow you to understand what you don't know. So the keywords, so first part is try to gain superficial knowledge and look for keywords that will allow you to expand your knowledge. So the keywords in the beginning are the most important parts because they create the surface levels that are going to allow you to expand into branches of depth later. So first part is figure out fundamental keywords about the process, which is goes into point number 2, which is depth versus surface. So you should be aiming to create a funnel because that's how learning works. It's the same process that computers do. So first part is you look for surface level. So watch a bunch of stuff very fast and don't worry about trying to hold information. Just get the keywords. Then the second part to understand is that everything has symmetry because that's what perception is. So you always have an observer and what's being observed. And that's a relativistic symmetry. So you have left and you have right, have object-oriented and you have composition, you have JavaScript and you have Python. And all the complexity of the universe is going to be behind, or is going to be in between this relative symmetry. So within different symmetries, you have other symmetries. So anything you're going to become good at is going to depend on the circumstances and the trade-offs of everything. So the process of learning is understanding what are the trade-offs and why do you do the trade-offs you do. And that goes into the exploration of differences in symmetries. So the more aware you are about that, the easier it's going to be for you to spot when there is a symmetry about something. And then you should be aiming to ask yourself the question of why. So in which circumstances is going to this side of the symmetry more or better than going to the other side? And that's basically what you're doing when you're learning. It's all about symmetry. Then the last point is obviously the one that I talked about, which is awareness and self-reflection, which is going to allow you to close the feedback loop cycle of this iteration, of the expansion of knowledge. Because you're always reflecting on whether or not the energy you're investing into something is congruent with your value system, which is the stuff that you began with, which is the end goal. So your curiosity. What do I want to build and why? And then you follow that. Then you go through this process of the expansion, depth versus surface, symmetry. After you expand, you're going to have questions. Those questions are going to lead to answers. The answers open up the branch of the game tree of your knowledge. Then once you get to the point, you reflect and you ask yourself, am I going to the right direction still? Why am I going to this direction? Should I go back or should I continue? And then that's the whole cycle. And the more times you go through the cycle, the easier it becomes to close the feedback, which makes everything is like a virtuous spiral. So basically, there are no shortcuts, obviously. And I think that you can't really avoid doing this because that's how life works, so how space-time works. But it's always going to be like a constant battle between your conscious mind, your subconscious mind, because you're trying to survive, so you're trying to save energy, minimize risk, but your conscious mind is trying to expand, because that's your spirit trying to do things. And then whatever is the rate of the thing is going to determine the rate of the frequency of your body, which is a paradox. So ultimately, it doesn't matter, just differences in values in people. So it's not that one thing is better than the other. It's just a matter of preferences and being self-aware of your preferences. Just see if you're congruent with who you are at that moment. Yo, no worries, man. I'm gonna put breakpoints on this because I think this is the function. So it's both this and the other one that is gonna call there, I think. It's gonna use the curve to build the Bezier. I'm gonna skip this for now. Just press F10 on everything. I'm pretty sure that I put a breakpoint on this one, the last function here. So I'm gonna press F10. Yeah. So I think that this function is important. Yeah, this is the function that's I'm pretty sure. Yeah, does initialize the geometry for the first time, I think. And the geometry is gonna be the thing that creates the mesh, if I remember correctly. And the mesh is the thing that is used to render the 3D curve. So here is the first part that it calls the curved legacy to curves. They're just translating the information for the first curve that it creates there. It does that by the NURBS list here. So the NURBS list contains the NURB, which is the stuff that creates the point in the first place. And it appends this to the source curves and then uses this to translate into the curves. So it initializes the curves with this curves new no main. Then on the second one is going to initialize the geometry for the curves, which is the class that keeps track of the attributes of the curve, I think. It's basically this thing here, I think. This is the giant struct there. And this is the part that is kind of, I think I'm not going to need to do this, but yeah. It's basically creating a bunch of functions that are going to allow you to create attributes to write and read from them. That are going to be stored on the curve geometry. Then later on, you call a function that is going to pass a bunch of callbacks that are going to use these other functions to change the values of the curve geometry. Let's see how much time. It's 13 minutes. I'm gonna stop here. I'm gonna go take a break. I'm probably gonna meditate for 20 minutes, and then I'm gonna come back. And I'm probably gonna when I come back, I'm gonna go from the point where I already have the curve, I think, because otherwise I'm gonna take too much time. Yeah, so like first step that I'm trying to do, I already converted, I think, all the functions that I need for the first part. So what I'm trying to do now is just convert the other functions for the second part to add the depth to the curve. After I have all the functions on the other project, then I start to clarify the connection between the data structures. So this is basically creating the stuff for the attributes. So as far as I remember right now, this is I think this is a function, but if this isn't, the other one definitely is. That is gonna allow you, so it's basically setters and getters, let's say, for each attribute on the curve's geometry that allows them to, when you're putting a depth, is gonna call these functions to read and write from the attributes, change the data on the curve's geometry, and that's what they're gonna use to build the vertices, I think. Yeah, so it is a callback function, I think. So it is a struct of callback functions. These are lambda functions in C++. So it just is basically getters and setters for the point data or curve data, which is the thing that holds the state, I think, for the curve. So maybe a little bit more. Just press F10 and everything. And this part's the one that is very confusing. I'm just gonna press F10, everything here. Because from this point, it's pretty close to. So it does all this reads, write stuff, holds here. I think after it's gonna have, it's gonna loop over these functions there, and then it's gonna update the state or the data for the points on the curve, I think. Yeah, so it's on this thing here, I put a breakpoint there on one of them. So it's basically passing callback functions from that function there. And the callback functions are these functions here. And then on these functions, it's gonna update the states of the points from the source points that initialize based on the source curve here. So I think it's updating the states of the curves structure with the data from the NURBS that initialize in the beginning. So this here, the span is a class that they use to, it basically creates an array, but on an optimized way. There's an array of base triple from the first place there that initializes the points on the NURB, and then is updating the values. So it's looping over each point, getting the point, and updating the values of the position for the curves. So basically updating the state, I think. Yeah, so this is the part in the beginning there, when it initializes the geometry, is like basically setting getters and setters, I think. This is probably gonna return a pointer, I think, true. Not really sure. It's probably gonna be a pointer. This position is a pointer for the array that contains the point data, I think. So it's getting the attributes based on this stuff here, I think. Attribute position. It's getting from the curves geometry that is a member variable of the curves, and it's going to update the data with that function there. And that function is the one that creates the Bezier curve. So it's basically storing everything on this custom data here, as far as I understand. The custom data is going to be either for points or curves, and are member variables of the curves, I think. So it uses the curve geometry to create setters and getters for different attributes that the curve is going to have. And then from those points, it's going to update this data. So the getters and setters are bridges between the, like outside, let's say, and the curves. And it does that with the curves geometry. So when it calls that function there on the create Bezier curve, it's just updating the values of the curves through the curve geometry by using these getters and setters, which is the attributes here. So it's essentially updating the value of this thing here, which is the data, I think, which later on is going to get this at some point. But obviously I still have to clarify this stuff here. I do remember there are some functions that it specifically calls vertices or vertex. But I think this only happens on the second part of the iteration there. So I'm just gonna step over this stuff. Because this part's still not creating the curve, it's just the first part. So it sets everything up. Just setting the data structures for the second part. It's just like initializing them in the beginning. So after it does all this stuff, it's gonna go over with the other, like with the overall cycle of Blender, and check for it. So this is the last. From here is already like the managing the overall loop that creates the whole Blender stuff, and checks for the events and stuff like that. So yeah, I'm just gonna press F5 and then basically, yeah, so it creates the thing in the beginning. So the next one that I'm gonna see, I think, is you click on the data and then you go into geometry. And this is the state that I'm interested on. It's both the fill caps, but I'm gonna look into the depth first. So I already set breakpoints there. When you change the depth, it's gonna stop. And this is basically what's gonna create the geometry, I think. So the first part is just creating the points. So there's two things now that I wanna clarify. One is this thing about the second curve that it seems that it creates there in the first part, and the one is how does it take the curve that it initialized in the beginning, which is on the data structure that it did the control flow here. So it's basically going to be these points here. how does it take these points that represent the curve, which is the one that it shows here, to actually create a depth, which is when you change the value here. So from this point, what happens? But I'm going to stop streaming now. I'm going to take a break to meditate, and then I'm going to come back and I'm going to continue stepping over from these points and trying to clarify this stuff that I just said. So see you then.